Hey guys, today we're going to look at carbonyl compounds. Carbonyl compounds, they're basically two. We have what we call ketones and aldehydes. So these are the ketones, then we shall have also the aldehydes. Now, carbonyl compounds conform to a general formula that is CnH2n and oxygen, whereby N is Cn, H2n and oxygen, where this N is the number of carbon atoms. So this is the general formula for our carbonyl compounds, and the functional group in carbonyl compound, it is going to be called carbonyl group. Now, since we have talked about having this general formula, it means the functional group, which is the carbonyl group, it will be looking like this. We shall have, maybe this is alkyl group, we shall have this carbonyl carbon, and we shall also have this R or X. Let me use X, whereby this X, it can be hydrogen in case it is an aldehyde. The X can as well be any either methyl group or any alkyl group, which is, it can be even ethyl group, meaning this R, it can be maybe Ca3 or CH2CA3 if it is a ketone. Now let's look at examples, and these are examples of aldehydes, But now what you should know that aldehydes, and if we have a parent alkane, which is, this is alkane, the parent alkane will replace the ending E with Al. That's why we are having methanol. Now this is coming from ethane, that's why we are calling it ethanol. This is coming from propane, that's why we are calling it propanol. Then this is phenyl methanol or benzaldehyde. It is aromatic. Then we are having 2-phenyl-propanol, and this is aromatic, so we are treating this benzene ring as a side chain. And we should know that the functional group, that is the carbonyl group, is given the seniority. Then say this is position number 1, 2, and this is 3. That's why we are calling it 2-phenyl-propanol, meaning the benzene is attached on the second carbon atom. Now the same principle is followed, that is when you are naming ketones. For example, if we have a ketone from propane, that is any alkane, so this is the last E, not A. We are replacing the ending E with 1 or none, so that where we had propane, it would become propanone, like that. That's how we name the carbonyl compounds. So basically we're having two, that is aldehydes and ketones. Now the examples of ketones, as I've showed you already, this is CH3. Now ketones, you should know the functional group is always found in the middle of the compound. Let me say we shall have alkyl group this side and alkyl group the other side. Since we have said we are ending with ONE, that's why we are seeing on all of them we're having ONE. And this aromatic one, this is called acetophenone. Synthesis of carbonyl compounds. How do we get carbonyl compound? Now synthesis, we can get oxidation. Now this oxidation, in case you want to obtain an aldehyde, it means you are supposed to have controlled oxidation. That's why I'm having acidified potassium dichromate here and heat. And remember, since I want to obtain, that is an aldehyde, which is CH3, CH2, CHO, this is propanol from propan 1-ol, it means I'm supposed to use limited, that is little, or I'll use a mild oxidizing agent, that is acidified potassium dichromate. But in case I decide to use acidified potassium permanganate here, it means I will not be in position to obtain a carbonyl compound, but instead I'll be able to get a carboxylic acid, which is none of my interest. So to obtain a carbonyl compound, that is an aldehyde, I strictly use a mild oxidizing agent, acidified potassium dichromate. Then to obtain a ketone, it means I should use a secondary alcohol. I use a secondary alcohol and I oxidize it. Now here, even if I use dichromate or permanganate, all of them will be able to work. Then I'll be able to obtain a ketone. Then we can have also ozonolysis. Now ozonolysis, we know these are some of reactions of alkenes. Now ozonolysis, here there is a step which is missed. Ozonolysis, we are supposed to use ozone, but since ozone is poisonous, we are supposed to use carbon tetrachloride as a solvent to absorb it. Then we shall have this reaction occurring at a temperature below 20 degrees. Then here we are supposed to form what we call an ozonide. Now this ozonide, this is the structure of the ozonide. We shall have one oxygen up there. Then the two oxygens are going to be down here. Now note, here we don't have a sigma bond that is in between. Then after forming this ozonide, the ozonide is the one that we are going to hydrolyze. Hydrolysis, we are meaning reaction with water. Hydrolyze in presence of zinc and ethanoic acid. Then in zinc and ethanoic acid, we shall be able to get 2 molecules of ethanol. Now the 2 molecules of ethanol is because we're having CH3CH. Now it means we shall get an aldehyde that is ethanol. Then in case it is not symmetrical, like here we are seeing CH3, CH2, CH, then CH2, CH3. It means to separate from here, we shall get this aldehyde, and also this side we shall get an aldehyde, which is here we shall get propanol, then here we shall get ethanol coming from this last chain here. Then in case the alkene is having a branch, that is a methyl group, next to or around this double bond, then it means when you see prints in the middle, then this side here we shall be able to get a ketone. Like here we are seeing we are getting propanol, then here I'm getting ethanol. Now in case the alkene is branched, then we shall get a chance of getting a ketone, but in case it is not branched, we shall get aldehydes. In case it is branched, then we shall get an aldehyde and a ketone. In case it is symmetrical, the way you are seeing the first one here, then we shall be able to get 2 molecules of aldehydes. Then we have another reaction, which is a reaction of alkynes, where we get any alkyne with water and corn sulfuric acid and mercury sulfate at a temperature of 60 degrees. Then we can be in position to get either an aldehyde or a ketone. Now for example, if I use ethine, I'll be able to get ethanol, but in case I use propane here, I'm able to obtain propanol. Now let me show you how this reaction is going to occur. How it occurs, it is very simple.